So far in our probability unit, we've looked at problems involving not, or, and at least one. In this video, we'll look at our last type of probability, conditional probability, which uses the word given. Let's start by looking at an experiment where we draw one card from the deck. What is the probability that it's a spade? Well, there are 13 spades out of 52 in the deck, so that would be 13 out of 52. Or reducing would be 1/4. Now let's change it slightly. I still draw one card from the deck, but I sneak a peek and I look at the card and I tell you that the card is black. Now that I've given you that information, what would be the probability that it's a spade? Well, if I tell you that the card is black, I'm no longer considering the entire deck. I know that it's a black card, so there aren't 52 possible cards that it could be. It can only be a black card, so it could only possibly be one of these 26 black cards. I've restricted the sample space to be only the black cards. So that's my new sample space, the black cards only. So the probability is no longer 13 out of 52. Since my sample space is only these 26 cards, it's 13 out of 26. Or reduce that to 1/2. What we just did is called conditional probability. Because you're calculating the probability under the condition that the card is black. We usually use the word given for this, given that the card is black. The notation we can use to shorthand a problem, the probability the card is a spade given that it is black, would be probability of spade given that is a vertical line, then black. So probability is a spade given that it's black. There is a formula for this conditional probability in your text, but I find it easier to think of restricting the sample space to only the set that is given. This set, as you read the problem, is always going to come after the word given in the problems. Example 1 says, one die is rolled. What is the probability that the roll is a 2, given that the roll is an even number? Well, normally when we roll a die, the sample space is going to be 1, 2, 3, 4, 5, 6. But now we are given that the roll is an even number. That's a restricted sample space. So the sample space is now only the even numbers. So our sample space is only the even numbers out of this group, 2, 4, and 6. Take out the rest. There's my sample space. So now when I want the probability that the roll is a 2, it's only out of this sample space, so it's 1 out of 3. So 1/3. Example 2 also talks about rolling one die, but it asks what is the probability that the roll is a 2 given that the roll is an odd number. So now the sample space would only be the odd numbers on a die, which would be 1, 3, and 5. So we still have 3 items in the sample space, but this time the answer is not 1/3. Why not? Well, we're looking for the probability the roll is a 2. Our sample space is 1, 3, and 5. How many 2s are in that sample space? Not on the die, but in this sample space, how many 2s? None. There aren't any 2's in that sample space, so the probability is 0. This is why it's so important to determine the sample space first by finding the given set. Number 1 and number 2 ask the same question. One die is rolled. What is the probability that the roll is a 2? They start out exactly the same way, so you can't answer that question until you know what the sample space is, what the given set is. We got very different answers to these two questions because the sample spaces were different as determined by the given set. Even numbers versus odd numbers. Example 3 says a card is drawn from the deck. Find the probability that the card is a king given that it is a face card, and then a face card given that it is a king. Always find the given set first because that is our sample space. The given set comes after the word given. In number 3a, we are given that it is a face card. So our sample space is the face cards. That means that this is not our sample space. The sample space is the face cards. This is our sample space, just the face cards. So in our sample space, how many of these are kings and how many cards are there total in the new sample space? Those will give us our numbers for our probability. So in this new sample space, there are 4 kings out of 12 cards. The probability is 4 out of 12, which reduces to 1/3. For part B, we want the probability that the card is a face card given that it is a king. Our given set is now the kings. That restricts our sample space even more. Our sample space for 3B is not the face cards. It's only the kings. This is not our sample space for part B. This is our sample space for part B. Just the kings. So to do the fraction in our new sample space, how many are face cards and how many are kings? Well, all 4 cards in the sample space are face cards and all 4 cards are kings, so the probability will be 4 out of 4 or 1. If we know how we have a king, it's certainly a face card, so the probability is 1. Notice that in 3B, it asks about face cards, but there is no 12 in this answer. I don't use 12 for the number of face cards because I'm not looking at the whole deck. I'm only looking at this restricted sample space, restricted to the given set, which are the kings. So in this restricted sample space, how many face cards are there? In this space, there are 4 face cards, not 12. Example 4 presents information in a table. We found probabilities in tables in previous sections, so we'll review those problems that we've already done and then extend the problems to include conditional probability, or the given problems. Example 4 says patrons of a restaurant were surveyed about the restaurant service. The results were summarized as followed. What meal did they have, and did they rate it good or poor? Looking over the 4 questions, parts A, B, and C in example 4, part A just asks the probability that they rated the service as good. That's just a basic probability question. Part B has the word or. So we'll need the formula for probability of A or B. Part C and D have the word given. On these parts, we'll restrict the sample space to only the given set. For part A, the probability the patron rated the service good will be the number that said good over the total number. That would be the total of the service good column, 115, over the total at the bottom right corner of the chart, 160. So 115 over 160 115 divided by 160 in decimal form comes out to 0.71875 or 0.719 to 3 decimal places. There was a mistake down here, I just corrected it. It's 0.71875 or 0.719. .71875 or rounded to 3 decimal places would be 0.719. Part B requires the OR formula, which was probability A or B equals probability A plus probability B minus probability of A and B. In other words, we add and then subtract the overlap. Well, probability of breakfast is the total of the breakfast row. Total of that row is 25 over 160, which is the total of the survey. Probability of poor, so rated the service poor, would be the total of the service poor column, which is 45 over 160. The overlap or intersection of the rows, the row and column, is 5. That's the number that both ate breakfast, because it's in the breakfast row, and rated the service as poor, because it's in the poor column. Well, those patrons were double counted. They got counted in both categories, so we subtract them out.